So today on our DagsHub learning webinar, we're going to talk about versioning and streaming data, and we're going to use DVC and DDA. So we're going to learn about DVC and how we can use DVC to version our data, and how we can use DDA to basically stream our data using a powerful API. We have here a link to sign up. So in the session today, we're going to use our integration, as I mentioned, with DVC to make the entire process easier, and it will enable us to also use a remote bucket to version our data and push it to that bucket. So it will be available for all the people that you're collaborating with. So if you want to follow along the hands-on experience part, please sign up to DagsHub using this link. Cool. So in our session today, we're going to cover 4 major topics. The first one is DVC 101. So what is DVC? How does it work? And maybe we'll start even with why do we even need it? Why do we even need to version our data? Then we're going to move to some basic DVC commands and how to use it. And from this point, we're going to embark on a journey of the hands-on experience session, where we're going to use DVC to version our data and build reproducible pipelines. And then we're going to stream our data, our DVC version data, using DDA. I see a message on the chat. So, okay. So Megan, I see your camera. So if there's something I need to notice, just like wave and I'll stop. Awesome. Cool. So let's start with the quick introduction to DVC. So why do we even need DVC? ML projects are heavily driven by research, and from using different data sets and annotations methods to hyperparameters tuning. And unlike software development projects, ML projects have different components that are different from each other in their core. So we have our code, which are basically simple text files. We have our data, which can be either tabular data, unstructured data, images, video, text. They can be very big, they can be very small. We can have a lot of them, models, experiments, and whatnot. And this fact holds a great challenge that many engineers work hard to solve, which is reproducibility. Say reproducibility 10 times. So this is something that we need a way to version, and because of this reproducibility problem, we need a way to version control all the project components to enable the reproducibility of all of our results and experiments. So it can be, if it's an experiment that we run, it's a model that we have in production and we want to go back and understand which data was used to train the model, what is the model, what is the data pipeline. If we want to deploy to production, so we don't only need the model itself, we also need the pre-processing step and the post-processing step. So we need the entire pipeline altogether. So you're probably asking yourself, maybe because you saw the next title, or maybe because you didn't, why not to simply use Git or Git LFS for versioning our data and our models? So Git was originally designed for managing software development projects and for versioning text or code files. Therefore, Git doesn't handle large files very well. And Git LFS is better than Git for large file versioning, but when scaling, it fails. And it also a one-door way. So the adoption or removal of Git LFS in a repository is irreversible. And also you're gonna have to set up a unique server for your Git LFS, which can't be modified or changed to a different provider, which is a pain for data scientists because they want to hold, or companies that want to hold their data on their warehouse. In addition, both Git and Git LFS are missing a lot of core capabilities. Let me kill the notifications here. They're missing some core capabilities that are for managing ML projects, such as the data pipeline or whatnot. And to overcome this challenge, a lot of powerful tools emerged in recent years, such as MLflow, Pachyderm, LakeFS, Dolt, and whatnot. You can read all about those tools and the difference between them in the blog here, or you can also read more in depth why Git is not enough for ML projects. But the one tool that stood out of the most when we did the market research, at least for DagsHub, was DVC. And I'm not trying to diss anyone else, because I really think that all other tools are very good and they are oriented towards different use cases and have different benefits. But DVC, and the reason that I love DVC so much is because it was designed based on Git. And DVC actually works as an extension to Git. So one can't coexist without the other if you want to manage and version your data files. Also, it enables managing and version control of all project components, reproduce results, share large files, and the list just goes on and on. I can just read it from here, but you can also read it through later on. And I think another powerful thing about DVC is that it's completely open source. So there is no vendor lock at any stage. You can move for other, or you can use it and move to other providers if you wish. And it's very well maintained. So it has 250 contributors. They have fast response to issues, to pull requests, and stuff like that. And also it's backed by Iterative, which is a very successful MLOps company that I think are doing wonders in the MLOps world. So now that we understand that DVC is a great tool and we want to use it, let's understand what is the workflow of Git and DVC, because we know that DVC is like an extension to Git. So if you're watching the recording of this session, I added a link to the YouTube video here, but you're not, and you attended this session, and you're also able to ask questions, which is a great benefit. So you're gonna win a personal demo of the workflow. So how does it really work? So let's say in our use case that we have our file system, our local file system on the bottom of the screen, the bottom right. We have our Git version files and we have our DVC version files, okay? Now we're adding another file to our project, the universe.txt. And as you can imagine, the universe holds a lot of great information and it's a very, very large file. So we don't want to use Git to track it. We want to use DVC to version it. So we're gonna use DVC to version this file. We're gonna use the command that's called DVC add universe.txt, which is gonna version this file. And by running this command, two things or three things are gonna happen. First and foremost, DVC is gonna version the universe.txt. So as you can see, it's version A. Then DVC is gonna tell Git not to track it, not to handle it. He's gonna tell Git, listen, I got it covered. So the way he's gonna do it is by adding the path to the universe.txt to a .gitignore file. And this way Git will be blinded to this file. But it's also gonna generate this unique file and very weird, the universe.txt.dvc. So what is this file? The .dvc file is basically a pointer file that holds metadata and a hash function and an MD5 hash of the version of the original file. So this file that we see here, I'm not sure if you can see my pointer, but I'm like circling around the .dvc file. So this file actually points, I see that Megan nods her head as yes, so you can see my pointer, great. So this file is actually pointing to version A of the original file, okay? And we're gonna use Git to version both of those files. So we're gonna add them to Git tracking. And this way, we're gonna use the pointer file and Git to go back and forth in time. And we're gonna use the pointer to find the version of our original file. So this is very hand-wavy. So let's see how it really works. Wow, this cool animation. Still some water. Cool. So this is our state of the project. We have our data file version by DVC and by Git. And let's say that now Megan worked very hard to feature and engineer it, and she created another version of the file, version B. How can we version this new how can we track this new version? So we're gonna start by versioning it with DVC. So DVC is basically behind the scene, is gonna create a copy of all the new files that were modified. So let's say you have 1 million images and Megan just added 1 more images. So this directory holds 1,000,001 images. DVC won't create a copy of all the 1 million images that it already saw. It will only find the diff between the versions and it's gonna create a new copy of it in its cache directory. Cool. So now we have version B, version by DVC. And by running this command, I'm not sure if you noticed, but the pointer file now was changed. It points at version B. But what we have on Git is pointing to version A. So what do we want to do? We want to version this pointer file using Git. So we're going to add it to Git tracking. And let's repeat this process again, because I know Yono is very enthusiastic about feature engineering. So we also created another version of our file. So version C, we're going to start by versioning it with DVC. Then it's going to create a new version of our pointer file. And this pointer file is going to be versioned by, correct, by Git. No one answered. I'm just kidding. So now let's say that we have those 3 versions, but we found out that Megan and Yono didn't do such a good job feature engineering our data. And we want to go back and retrieve version A of our file. How can we do that? So the workflow is pretty straightforward. What we want to do, we want to use Git and its superhuman capabilities of going back and forth in time and retrieve our pointer file. So what we're going to do, we're going to use the git checkout or the git reset command, and we're going to find the file that we want to retrieve back. We're going to retrieve its version. So we're finding version A in our Git cache or Git remote server, and then we're retrieving it back to our local machine. But now what we have version C of our data and version A of our pointer file. Next, we're going to use the pointer file and DVC to parse our cache and find version A in our cache. Note that the cache can be either locally or on a remote storage. So we're going to use DVC checkout or DVC pull, depends on where the file is stored. So now we're going to find version A and we are going to retrieve it. That's the workflow. So now we went back in time and retrieved version A of our universe.txt file. And with that, we're done with our high-level overview of the workflow. And we're going back to the notebook. If you have any questions, I'm going to take a sip of water. So it's good time to send it on the chat. So feel free. Lots of questions. Hello, good presentation. Thank you. So kind of you. Good feedback, positive feedback is always great, always acceptable. So I'm continuing with our notebook. So how does DVC actually handles the versioning of the file? So this is like a bit DVC internal. So if you're not following along, it's okay. But if you want to know how does it really works and what is this MD5 hash that I was just mentioning, this is the part. So DVC version files are actually stored when DVC version files. It's actually stored them in a hidden cache directory under a .dvc directory. So what you see on your computer when you open your operation system or your directory and you see a file, it's actually a link to the original file that is stored on the local cache. So let's say that in this case, we version the model.pickle. So we created the model.pickle.dvc, and DVC actually took this original file, stored it in the local cache, created this weird hash that we're going to cover in a second how it does that. And then it created a link. So it can be reflink, symlink, depends on your OS. And the pointer file that we have on our here that is versioned by Git is actually pointing to this file in our local cache. Okay, so this is actually linked. If you want, you can cancel this way of versioning, but what it means, it's going to create duplications of files. So it's not very recommended. I would use the default way of the way of DVC is versioning files. And how does DVC version single files and directories? So for single files, DVC calculates the file hash. It's a 35 characters, which is 256 bytes, which was very important to Yono for me to mention it, which is a long string, usually an MD5 hash. And as the DVC basically takes the first 2 characters of the hash, and it uses it as a directory, and the rest of the hash is the file name. So let's say if it calculated this hash, so EC is going to be the name of the subdirectory under the cache, and the rest of the hash is going to be the name of the file. And this is actually the original file. Okay, but what if we have a directory filled with 1 million images, as we just said? So basically, DVC will version each of the file in the directory, but it's not going to generate a million pointers. It's just going to generate one pointer file that points to the directory. And what does it really hold and how does it work? I think the best way to explain it is by using an example. So we're going to use this example where we have a data directory with two files, file 1 and file 2. And let's say that we version it with DVC. So we ran DVC add data, and this will generate the data.dvc pointer file. And for this example, this is going to be its content. So we have the MD5 hash here, but what you can see that is different is that this MD5 hash has an ending of .dir, unlike the file that ends that doesn't have an ending. So what is this really .dir convention? So let's find the pointer file and see what it has. So it starts with F4. So if I'm going to go to F4, so this is under the DVC cache directory, I'm going to see here this file. So this .dir directory is basically not a database, but a mapping way for DVC to map all the rest of all the content of the directory to those hashes that it has in the cache. So in this case, if we're going to go and check out what this file holds, so what this pointer file holds, we're going to see that it's like it holds a lot of dictionaries, each one with a unique MD5 hash and the real path in the directory. So the file number 1 has this hash and file number 2 has this hash. So basically DVC knows how to map the files in the directory to the relevant hashes. So far, so good. Okay, so we covered why we need DVC, how DVC works at a high level, what is the workflow with Git, how DVC actually versions the files. And now let's go deeper into a more advanced feature, which is how DVC creates and builds or version data pipelines. So what are data pipelines? So as we just talked about, ML project has the machine learning model, but it's not a standalone. It has the pre-processing step and the post-processing step that without them, the model is basically meaningless. So we need to deploy the entire model to production with all the steps. And also when running a machine learning training process, it has a lot of different steps along the way. So from data collection, annotations, processing, feature engineering, building the model, training the model, exporting a model, and then testing the model. So all these different components are interacting with each other, and they usually are a one-way ticket. So meaning it's a one-way stream. It's a better way to say it, or direct async graph. I think DagsHub represents it. So basically, DVC enables us to build those graphs. What we can see here is our support to DVC pipelines. So basically, this is a presentation of the pipeline that DagsHub provides. And I'm not sure if you can see it. Let me see if it's going to enlarge it. Yeah. So sorry for all the spammy ads. So in this case, we have a training step that the dependency for this step is a process data set that is versioned and managed by DVC. We have 2 Python files. And when running this step, so basically running a command, it outputs model and a parameter YAML file and metrics CSV file that holds all the metric of the training process. So how can we really build it? So let me go back to the notebook. So to build the data pipeline, we're going to use the DVC stage add command or the DVC run command. And this is not very interesting. We're going to see how we can do it in a later stage of the webinar. But what's more interesting is how DVC does that. So basically, when we run a DVC, one of these commands, DVC will start by creating a dvc.yaml file. And this file basically holds all the information of the pipeline. So what we can see here is a presentation of this pipeline. So we have the first stage, which is the training step. We have the command of the step. So basically each step, as we mentioned, is a command. So in this case, we're running the train.py script. It has dependencies. So data process, which is our data set. We have our Python files, and the step has outputs. So our models. So it's basically a trained model, the weights of our trained model. We have the parameters, and you can see that we're telling DVC not to track it, and also metrics. And what you can notice from now is that DVC in the pipeline also holds information about non-DVC version files. So we have Python scripts here, we have YAML files, CSV, very small files that we want to use V2 version, right? So why does DVC really cares about them and does actually version them? So let's see that it versioned them first. So this is the .dvc log file. And basically this file holds all the versions of all the files that we have in our pipeline. So you can see that each file has this MD5 hash. So this is a directory. So it has the dir ending, as you can see, with the file size and the number of files in the directory. For the Python file, it has its hash and its file size, and so on and so on. So it holds the version of all the components of our pipeline, right? And why does it really does that? Does anyone have an idea? Let's do it a bit interactive, which is also a good time for me to take a break and drink. Oh, I see we have questions. Megan, we have questions. Okay, Kirill, are you taking the questions? Why structure of the directory is stored in a JSON file and not YAML file or JSON lines? This is basically the implementation of DVC. Probably it was easier for them to parse it and find the connect between the, okay, I'm gonna read first the question out loud and then I'm gonna answer it. So Jacob asked, why the structure of the directory, the MD5.dir, is stored in a JSON file and not a YAML file or a JSON line file? So as for my understanding, and maybe, Kirill or someone from the DVC team, if they're here, will answer. But from my understanding, it's a more efficient way to later on map or find which files were modified. So compare between what we have in the .dir file and the hashes of what we currently have on our directory. We need to know the size of the file. It's a question or an answer. Sumash? Water. Okay, I'm gonna get back to it in a sec. So continuing from where we left it. So we see that DVC also version Python scripts or Git tracked files. Why does it does that? Why it does that? Because think that you have a very, very long pipeline. Let's say we have a company, not to say their name, but their processing step takes a full week. And then the modeling step takes another week. So end-to-end running the pipeline takes 2 full weeks. And let's say that now Megan worked, or we took Megan too much, so we have Loren here. So Loren built a new model and we want to train the model. Should we process the data? We don't need to process the data because we didn't change anything in the processing step. So we're usually gonna modify the Python scripts there, right? So what DVC, and it does it very smartly, is versioning all the files in the pipeline, and it can detect which file was modified. And based on if it's a dependencies to a step, it's gonna start running the pipeline from this step. So let's say in our case, we have only one step, but let's say we modified the configuration of our training process, then DVC will know that it needs to run from the training step and not from the processing step, let's say, okay? So that's the main idea behind versioning all the files in the pipeline. So moving to the spreading the love here. So DagsHub integration with DVC. So we basically integrated DVC into DagsHub 2 years ago in 3 different phases. The first one is to enable users to, in the mindset of building a centralized place to build machine learning projects, we basically wanted to host all the DVC version files and view them on the DagsHub repo. And this way you can view your data files next to your code files. So what we enabled is basically to plug your S3 bucket to DagsHub and basically proxy the data that you from the bucket to DagsHub. And we'll be able to show you your data next to your code files. And we understand that this is great and all, but data is at the base and core of every ML project. So we need to treat it as first-class citizen. So what we did next is to enable reviewing, diffing, communication, merging, basically everything that we can do for code files, but also to data files. And we support many formats like images, video, CSV, audio, whatever. And the next step or the next phase was more community oriented, where we also actually have companies that using it. But basically we added a remote storage that is fully configured with every repository that is live and connected to your repo. So it's basically an object storage that is connected to every repo that you have on DagsHub. And we're generating 4 lines of commands, DVC commands, we're going to see them later on, that enables you to connect or configure your machine with that remote storage and start pushing your data. So no IAM roles, no heavy DevOps doing. We did it for you. All you need to do is copy those 4 lines of commands, run them, and then you can version your data, and it's all team-based access. So if you can write to this repo, you can also push data to it. And after we did that, we still faced a fundamental challenge for data scientists in accessing and uploading the data. So the data management is done on a version level, rather on a specific file granularity. And this is exactly something we need when we do intense data work, such as exploratory data analysis, data processing, what Megan loves to do best, which is feature engineering, and so on. And also, when we want to append file to a DVC version directory, what we need to do is actually pull the directory to our local machine, add or append this one file, recalculate the new MD5 hash, and push it to our bucket. So what we decided at DagsHub to do is to build an open source Python API and client that will enable an easy access to DVC version files that are hosted on DagsHub. And this is basically mean that you can use an API to access our data, which is much more flexible. We can stream our data in batches, so we can start training the model without waiting for the entire data set to be downloaded. And also we can download subset of the data or specific files that we have on a directory. We can append files to DVC version directories. So what you can do is upload the file, and using our backend capabilities, we're going to recalculate the MD5 hash, and we're going to add it to your directory. And the best part of it is that you can enjoy the best of both worlds. So you can use the management of DVC from the CLI, but enjoy the API accessing, the data management accessing through an API. And how does data streaming really works with DDA? So basically, we're using Python hooks that automatically detects calls to Python built-in operations, such as open. So whenever you're trying to open a file that is versioned by DVC, we detect it, we parse it, and we check if it exists also on DagsHub. And if it does, we're using HTTP requests to basically download that file to your local machine. It supports different methods, different platforms. So I welcome you to check the support metrics before getting started, so you know what it supports and if it's relevant for you. Okay, we spoke quite a lot, 30 minutes, because we started at 8:05 or 1:05, depends where you're joining from. And I think it's time to move to the hands-on experience. So once again, if you want to follow along this session, Megan, please resend the notebook so everyone will have a link on the chat. And we're going to dive into the hands-on experience. But before that, I'm going to pour some water. I'm going to drink some water because I'm dehydrated. Any questions on the chat that I should answer? What does DDA mean? Oh, Jacob, you have great questions today. So DDA is direct data access. So this is what it stands for. And is there a CLI support plan similar to VFS for Git? So not at the moment. What we do have is another open source CLI tool that basically encapsulates both Git and DVC. We name it FDS. I wanted to ask if you'll know the initials, but it's going to be too hard. So it's Fast Data Science. And basically using FDS, you can use one tool instead of two to version your code files, your data files. And basically when you're going to run FDS add, and then all the files that you want to add, we either going to use some heuristics to choose which files to version with which tool, or ask you which files you want to version with which tool, and behind the scenes, we're going to do it for you. How does the cache storage in S3 affects the speed? By speed, I mean when we perform the DVC pull operation. So basically, when you do the DVC pull operation, it uses the pointer file to parse the remote storage, find the files that you want to pull, and then it pulls it to your local system. So it really depends to what you compare by when you mean speed. So downloading directory, like directly one file, or using DVC, I don't think I checked for benchmarks. So if anyone knows if there's like a benchmark or the difference between the two, I'd love to hear. But as far as for my knowledge, it's not very significant at all, even I would say. Drinking water. Okay, Kai, thank you for the question. Kirill, if you can take it, I'm going to continue with the webinar. And if not, I'm going to go back to it when you're going to finish the hands-on experience. So what we're going to cover in the hands-on is basically configuring DagsHub storage with your local machine. In this case, our machine is going to be Colab. Next, we're going to use DVC to version large files and push them to DagsHub storage, build reproducible data pipelines with DVC. Then we can view, compare the DVC version files on DagsHub and use DDA to close the loop to stream our DVC version files. This is a disclaimer, and I'm going to use Yono's catchphrase, but so forgive me for that, Yono, for stealing your thunder on this. But this is a live demo, and this is a big disclaimer, and probably everything will go wrong. So please bear with me. And also send your prayers to the demo god that everything will go smoothly. This is very challenging doing live coding. So I hope everything goes as planned. So about the project that we're going to use. So the objective of the project that we're going to use is basically building a neural net to recognize urban sounds from 10 different categories. We're going to use Python Liberius package to extract numerical features from the audio clip and then train a neural network. The data set we're going to use is the Urban Sound 8K. We're going to use a thinner version of it just to reduce that data transfer time because I don't want to waste time on downloading. I want you to see how to work with DVC. But basically, this data set has roughly 9K label sounds from 10 different categories, from air condition to car horn and children playing. You can view the full data set on DagsHub or simply check out this. So this is cool, and we're going to see it more. It's going to connect to the runtime. I just checked that I'm using GPU. Great. So this is the project on DagsHub. If I'm going to go to the audio data. So this is stored on the bucket on DagsHub storage. I got it. Thank you. So this is the audio file. When we did a dry run, Yono wasn't able to hear it. So I'm going to try and play it. Let me know if you can hear it. Megan, thumbs up if you can hear it. Nothing. Okay, so there's a bunch of gunshots in this audio track. So basically you can hear listen to the audio file. You can view its audio wave and see its spectrogram. So it's pretty neat. And this is the data that we're going to use. And this is the structure. Okay. So we're going to start with some DagsHub configurations. So if you're following along, just fill in your username and your email. and here we have some constant, so just run it. Next, we're going to generate an access token from DagsHub using the DagsHub API. So just type in your DagsHub password. Don't steal mine. And now what we're going to do, we're going to use DagsHub client to actually create a repo on DagsHub. So we're going to start by installing the DagsHub client. And then we're going to create a repo. Let's try to import it just to make sure that it worked. Yeah. You didn't send your prayers to the demo god. Come on, guys. I need you with me. Send your prayers. Okay, it works. So we're gonna start by creating a repo. So basically what it's gonna do is gonna use this name of the repo that we have here, Urban Audio Classifier Demo. It's gonna use your token and your username to generate it. So let's run this cell. It's gonna send you to the OAuth. I'm gonna accept it. I'm gonna copy, I'm gonna paste, I'm gonna enter, and I'm gonna create a repo. Let's see that the repo was created. Awesome. So we have a repo on DagsHub, the Urban Audio Classifier Demo, and it's empty. It only has a git ignore. You can also do it from the UI, actually. Shout out to Anna, our UI UX designer. So it's very neat, check it out, but you can also do it from the client and the API. Next, we're going to configure Git. So this is not very interesting. And we're going to clone the project from DagsHub. So we can clone it from using the remote button, then take the Git remote, copy it the same way as with GitHub. Here I pre-configured it. So all you need to do is basically run it, and it's going to clone the project, and it's going to change directories to the project. Let's see that we have it. Awesome. So we're here. We have the Urban Audio Classifier Demo here. We have the Git directory and the Git ignore directory. Awesome. Now we're moving to the DVC part. So we're going to start by installing DVC. So DVC can be used as a Python library and is managed by package managers like pip or conda, or it can be used as a Python project requirement if needed. So please note that DVC does not replace Git, and it doesn't include Git in it. So to use its core features, you also need to have Git on your system. And if you want more installation types, you can visit DVC's docs. So I'm going to start by running the DVC install. And while it's running, we're going to cover the initialization of DVC. So the same as with Git, to start using DVC, we need to initialize it. And to do that, we're going to run the DVC init command. And just note, to run it, you're going to need to be inside a Git repository. If not, DVC is going to shout at you and going to say, warning, or can't do that because you're not inside the Git repository. And this is mainly because using DVC without Git doesn't mean a lot. You can't really do anything. DVC is an extension to Git. It's an awesome tool. It's a great tool, but it's built on top of Git. So to do that, we need to be in a Git repository. So we install DVC, and now we're going to run DVC init. So this is what we're going to see when we're going to run it. And when we do that, we're going to see that we got a new DVC directory here and a new .dvc ignore file. So this is the structure of our project now. And what those files or directory holds, so the DVC holds all the configurations of DVC, the cache, the git ignore, everything. And the .dvc ignore file is basically the same as git ignore, but for DVC. So moving along to configuring our remote storage. And for that, we're going to use DagsHub storage, because if you want to configure an S3 bucket, then we're probably going to need to choose a cloud provider, sign up to the cloud provider, give our credits to it, then create an IAM role, open a bucket, configure the bucket with our local machine, use their CLI tool, and then start figuring out how to push their data to it, and also to view it on DagsHub. So to make this process shorter, all we need to do is go to DagsHub, click on the remote button, copy those 4 commands that we have there. So the first command is basically setting up a remote origin. And the last 3 are basically configuring our credentials with this storage. So the first one is going to add a new remote. It's going to name it origin, and then it's going to give it its URL. So as you can see, it's your DagsHub URL.dvc. And you can immediately see that I'm also in the last 3 commands, I'm using the local flag. And what does it really mean? It means that these configurations are going to be stored locally and no tool is going to version it. And why it's so important? Because you don't want to push your credentials to anywhere. You want to store them locally and not have anyone have access to them. So this is why we're using the local flag. Okay, so let's run those commands. Yep. So we're running those commands. We'll basically configure everything. You can run this. You don't need to change anything. We're using variables here. So if you're following along, no need to change anything. Next, and another good practice is to set a default remote. So by running the DVC remote default and setting the origin to be the remote, the default remote, we'll basically every time we're going to run the DVC push command, it's going to push it to origin. But this leads us to another point that with DVC, we can have multiple remotes. So DVC doesn't lock us to one cloud provider or one remote. We can basically have one remote to our data set, one remote to our model, one remote to what we have in production, and so on. So this is another thing to note here. So I'm going to run this, and I'm going to drink water. Got it, drinking a lot. Yeah, I got water. Now let's check what happened on our repo. So I'm going to run the git status command, and we can see that we have the git ignore file, a new git ignore file, a new .dvc file that we already saw, and we also have the DVC configurations that are new and also modified. So we modified our config files. I'm not going to open and show you the configuration files because then you're going to be able to see my token. But if you want to go and check it, then just run command cat and then .dvc/config, and it will show you its content, and you're going to be able to see how DVC stores the information about the remote there. Okay, so now let's version those files with Git. So if you recall the rule of thumb, okay, you don't recall because I haven't mentioned it yet, but the rule of thumb here is every file that ends with .dvc will be versioned by Git. Why? Because those are very small files, and we're also going to use Git to go back and forth in time with those files. So we're going to run the git add, commit, and push. And now let's see that we have all of our configuration on DagsHub. Awesome. So now we can see that the .dvc here is here. Let's go to the configuration and see if you can see my token. So no, you can't, because I stored it locally. I used the local cache, the local flag. So here you only see my DVC configurations that are public and that I pushed to DagsHub. Cool. So now let's start versioning some code and data. So I'm gonna run this, which is basically I'm gonna download a requirement.txt file, all the source code of our project, and our data set. Using the DVC get command is basically downloading files or directories from DVC or Git remotes without versioning or tracking them. Okay, so these files that are now going to be downloaded are not versioned by Git or DVC. So now let's see what is the status of the project. So it's extracting now, so it's going to take a sec. Awesome. So now we can see that we have 3 new files. The audio data, which is our data set. So this is it. We can see that it has all those audio files. Yeah, it got stuck. All of these are audio files. Now let's see if you can hear it. No, it's gonna, okay, never mind. So this is our data set. On the source code, we have the data and model. So here it's like the data generator, Python script. And the model holds the training, the model architecture and the training, and also have constant file. So let's start versioning some files, shall we? So the first thing that we're going to do is run the pip install. So while it's running, we're going to go to the versioning part. So the first thing that we want to do is version our data files, and we're going to do it with DVC. And as I previously mentioned, to add or to version a file with DVC, what we need to do is run the DVC add command. So what we're running is DVC add, and then the path to the file that we want to add. So in this case, we are in the root of the project, so the path is audio data. So we're just going to take a second to run. Meanwhile, while it's running, let's see if there's something in the chat. Yeah, so Kai, I'm happy that the demo is going to answer your question. This is the greatest question because I have answer to it, a prepared answer to it. How is everyone hanging? Are we cool? Are you with me? Give me some thumbs up in the chat just so I'll know that you're alive. Give me a heartbeat, as they say. Anyone on the chat, some thumbs up. Megan, be the first one. Come on. Awesome. Thank you, Dimitro. Megan, Kirill, Arno, thank you all. Thank you. You are alive and well. Lauren, Mauricia, shout out to everyone. Awesome. So pip installed everything. So now we're ready to version our data. So let's run the DVC add command. So DVC is adding it, adding all the files, calculating the hashes, doing its thing. And we see that everything was versioned. And DVC is very kind, and it prints for us the commands that we need to run in order to version or track our files. Or if you want DVC to do it automatically, so everything that we're versioning with DVC then creates the DVC pointer file and the git ignore file, then DVC will auto stage it with Git. But before we do that, let's see what those files hold. So if I'm gonna run the cat for the pointer file, we can see that it has the MD5 hash, which is a dir file. We have the size of the directory, the number of files. So we have roughly 900 images and the path to this directory. And now let's see what this pointer files holds in the cache. So I'm going to go to my cache. I'm going to use the first two characters as the directory and the rest as the name of the file. I'm going to run it, and voila, I can see the mapping of all the MD5 hashes to the real path of the files. And this is how DVC holds all the hashes. Oh my God, so many hashes for our directory and all its content. So now let's also diff the git ignore file, and we can see that it added the path to the audio data, so Git will not version it. And now let's push our data to our remote storage. So what we're going to do here is run the DVC push command. I added the R flag here, but if I'm going to also delete it because we set the remote to be origin to be the default remote, it's also going to work. So let's try it out. Awesome. So it works. But I'm going to add it here just so you will see it, because this is important and might be cause to a lot of issues. So while DVC is pushing, let's move on to, yeah, we can't move on because there is a surprise. Okay, so it's going to take a sec to upload. 33%, 40%. No, it's probably fast for you, so you can see 50%, 54, 57, 62, and 68, 73, 84, 88, 92, 93, losing count. All files were pushed. Amazing. Let's go to DagsHub and see them. Okay, we can't see them, but this is okay. I was just me acting. So the reason we don't see our data files on DagsHub is because we haven't pushed our pointers file, our pointing files to DagsHub. And the way that our mechanism works, so DagsHub under the hood, you can call it, is basically that we're taking the pointer file that you have in the specific Git commit that you see here, because what you see here, it's the tip of the main branch. And we're parsing the storage to find the corresponding data files to that pointer file, and then represent them. Meaning, if you don't have the updated or the file itself of the pointer file on DagsHub, you won't be able to see the data file. So it doesn't mean if you pushed your data, it's on the storage, but it's not shown on DagsHub. To see it on DagsHub, you need to also push the relevant pointer file to DagsHub. So let's do that. So I'm going to add the pointer file and the git ignore to git tracking, and I'm going to push it to DagsHub. And now let's go to DagsHub and see it. And voila, magic. We have it here. We have the audio data file. Let's go see that we have some files here. And amazing. We have it here. This is a dog barking in my ears. Awesome. So now let's version the rest of the project. So let's run a git status to see what's going on. And we see that we have those two file, one the requirement.txt and the other one is a directory, the source code. We're going to use git to version both of them. So let's run the git versioning commands and push it to DagsHub. And now if we're going to go and check out DagsHub, we can see all of our projects on DagsHub, our code files, our data files, and everything there. Okay, so that was nice at all. And we learned how to version our data and push it to a remote storage and understand how the versioning process is going on. But now we want to start training our model. So what we rather do, instead of just running Python train.py to train it, we want to build a data pipeline. So we will use all the stages. So we will encapsulate all the stages in one pipeline. So for that, we're going to use the DVC run command. So what we have here is the dependencies. So first of all, the DVC run command, then the name of the stage that you want to use. So here we're giving it the train name, then all the dependencies that are marked with the -d flag. So we have the data set, we have a CSV file in the directory of audio data, we have our source code, and our constant. Next, we have the outputs, which are models. And this is a large file because this is going to be a directory with all the trained models. And the flag that we're using here, it's out persists, meaning when we're going to rerun the pipeline, DVC by default deletes all the outputs. And if we're going to use this flag, DVC will not delete it until we're finishing, until the pipeline ends. So it's going to basically replace it. So this is important. And then we have two other files that are fairly small and we don't want DVC to track them. So the convention here is to use capital letters. So the out stands for output that we don't want. So the big O is for output that we don't want DVC to version. So it's for the parameters. The big M is for special files that are metrics. And also DVC will not version it. And the last one is the command that we want to run. So it's going to be Python -m and then the code that the training code that we want to run. So let's run this pipeline. And while it's running, I will tell you that what's going on with audio in the audio domain is that usually in most cases, the processing step is done before the training step. So many of the libraries, probably 99% of them, are processing the data and then starting to train the model. So if you want to do it on the fly, we need to customize our generator and our function to do that. And this is a hint to the next part, which is going to be about streaming our data with with DDA. So what we see now is the Liberius library that processing our data. And then when we're going to run the git status, we're going to see that we have those two files. So let's see what the DVC YAML file is going to hold. So the name of the stage is going to be train. The command that we're going to run is the Python 3. We have the dependencies here. We have the outputs with all the flags that we use. So persist true, param YAML cache log file that holds all the MD5 hashes.
Go back for a sec, you froze.
Now I'm good.
Yeah.
Okay, so the YAML file, starts from the YAML file. Okay, so we can see that it's already training. Awesome. So the YAML file holds the command, the name of the stage, then the command that we want to run in this stage, then all its dependencies, and the outputs that are based on the flags that we use. So if it needs to be cached by DVC, persist, etc. And the DVC lock will have the same structure, but with all the MD5 hashes that are calculated for every file. So now that everything ran, the pipeline ran, let's run the Git status. And as you can see, the Git ignore was modified because it added the models to it. We have the new DVC lock and DVC YAML files, and the output, which are the parameter CSV and the parameters YAML and the metric CSV that are basically the information about the experiment. So the metrics, the results, and the parameters that we use. So now let's go and version all those files with Git, because the lock file and the YAML file are being versioned by Git. The rest are fairly small files, so Git is going to version them. So we're going to version them and push them to DagsHub. And then let's see everything on DagsHub. So as we can see, we have here the metric file, the parameters YA file. We have the models, which is a new directory with our trained models. We have all the different files. But the coolest part, which you look at this beauty. So we just created a new pipeline, and this is the presentation of the pipeline on DagsHub. And if you're going to want to go to the file, you can click on it and you go to the specific version of this file. So if I'm going to go to the const file, it's going to take me to the version of it. So this is at the tip of main. So this is why it's not taking me to a different commit. Awesome. So we are reaching to the last part of our webinar, which is using DDA to stream our data. And because it's fairly easy to use, this part shouldn't take more than 2.5 minutes. So I'm sorry for stealing 5 minutes of your time, so go in extra time. But it shouldn't take long now with DDA. So to start fresh, I'm gonna delete everything. So I'm gonna delete the directory, I'm gonna delete all the data, everything, and I'm gonna reclone my project. So now we can see that I only have the Git tracked files here. Okay, we don't have the model, we don't have the models here, we don't have the data, we don't have anything. Okay, so like a magician, there's nothing underneath it. Cool. So we're going to start with installing the requirements. We don't really need to because everything is going to be satisfied because we're using the same runtime. And also we're gonna need to redefine all the local configuration of DVC because we didn't push them to DagsHub. When I'm going to run it, it's going to mention that this already exists. So it's going to scream at me with an error, but it's not going to do anything. So this is a great thing to know, that if you named a remote and you want to change it, what you can do is use the force command to override it. Personally, using force feels way too force. I'm not into force. I'm not a force person. But so be careful when using it because you can delete things. Okay, so now what I'm gonna do, because as I mentioned earlier, all the packages now that are processing audio files are doing it before the training process starts. So this is meaningless for DDA. What I did, I basically built a data generator from scratch that also processed the data on the fly. So you can check it out here. Shout out to Jinan who helped me with this. But basically, we are processing the files on the fly and then creating a cache to store all of our processed data. And then we're gonna access it if it's already been processed. So no need to pre-process it again. And now what we want to do, we want to install the DagsHub client library to set up DDA. Next, we're gonna log in. There are two login methods. I'm gonna use this one. You can read more about the login ways. And now what we need to do is simply add 2 lines of code, and we can start streaming our data. Okay, this is the only 2 commands that you need, or code, or the 2 lines of code that you need to add in order to stream your data. I'm going to use 2 others. So one is I'm gonna want to use a subset of the data. So what I'm doing, I'm reading a CSV file in the project, and then based on the data on the rows in the CSV file, I'm training the model. So if I'm going to only, so what I'm doing, I'm basically downloading a CSV file which is fairly small, and then I'm loading only 3 rows of it. And then on the training process, I'm going to only download a subset of my data. So I'm only going to download 30 audio files to my local system. And this is amazing, because think of if you have a better heuristic on which data files you want to use to train your model, and not just the first 30 rows. This way you can only download a fairly small CSV file, choose the file that you want to use, and then use DDA to stream the relevant file. So this is file granularity and not version level. I love the word granularity, and Dean was the inspiration to it. So shout out to Dean. And we're also gonna modify the const file, because CUDA streams with us if we're gonna use too big of a batch with too little of data. So I'm gonna go to the training script. Where I'm using, let's do it a bit smaller. I'm gonna copy those 2 commands, take it all the way down. I'm gonna edit here. So we're importing the streaming, the install hooks, and then we're running the install hooks. And then when I am reading the data set, I'm going to use n rows. Oh my God, I'm scared to write code live. Yeah, live coding in interviews. Oh my God, I hate it. And then we are going to also modify the constant file. And instead of 128, we're going to use 16, which is awesome. And that's it. Magic. Now, are you ready? Let's run the training process. So by running this training process, yeah, I need to, oh, yeah, I do need to run this. So live coding, huh? I didn't add MLflow to the requirement. I jinxed it, huh? Drink water meanwhile. You know what? Yeah. Okay, so we're ready. And what is going to happen behind the scenes is basically we're gonna start training our model, processing our data, and this is basically downloading. Each row is downloading the data, the batch of the data, and processing it, saving it to cache, and then once it's gonna done for one batch, yeah, it's gonna start the training process. So here the training process starts, and you see that we're on epoch 2, and this way we didn't have to download the entire data set, and we're running all the epochs, which is amazing. And we are predicting that the sample that we used is, I don't know, it's gonna be a dog bark. Amazing. Note that this is very poor results because we're using a very small data set. It's only 30 images, sorry, 30 audio files. But this way, we don't need to pull the entire data set to a local machine. What we can do is use the API and DagsHub client to stream the data, choose the file that you want to stream, and do it easily. There's additional capabilities such as upload. So let's say you finished your training process and you now want to close the loop and upload some samples. You want to upload your model, the trained model. You can also do it from the client API. But this is a bit out of scope, and if you want to check it out, we have it on our docs. So 10 minutes behind of schedule, so I'm very sorry for stealing those very precious minutes from your day, but hopefully you gain a lot of knowledge in those 10 minutes. I'm going to start sharing screen. and I'm going to open the stage for questions. So people that want to stay here and ask questions, you are more than welcome. If not, thank you everyone for joining me today. It was huge fun preparing it, and even more fun to giving the session to you. If you have questions, feel free to reach out now. We also have our Discord. We have a link to our Discord on the notebook, which Megan is just going to share now in the chat. And the stage is open for questions. So if you have a question, use the raising hand icon here, and we're going to open your mic, or you can do it on the chat. Thank you, Dipli, and thank you, Venda. Thank you all for your kind words. Thank you all, Brian. Thank you also, Byron. The stage is open. Thank you for joining, Max. Also, I don't know if it's the right Erno, then shout out. Been a long time. Also, Philip. I'm guessing it's the right Erno and the right Philip, but if not, then hopefully you can accept my shout out. Thank you, Mert. Hi. Didn't saw you there. Awesome. So I think that with that, we can, yeah, that's you. Awesome, Philip, missed you. Let's catch a virtual coffee. Sorry for doing it publicly, but ping me on LinkedIn and we can grab a virtual coffee. Jacob, how to use DVC on different data sets? What do you mean by different data sets? Where to store them? You want to open your mic? If you want to open your mic, this is a possibility. Just let us know in the chat.
Yes, I mean that you have, for example, two data sets to train on, and you want to compare the results on one data set and on the other. This
is a wonderful and a bit deeper or more advanced question, which I love. So thank you for asking. So the way that we recommend doing that is basically treating data as registry and holding your data set in different registries. So let's say it's very different data sets. So one is, I don't know, Coco, and the other one is Cityscape, okay? So what you want to do, you want to store each one on a different storage. So in the way that we're building it, so each one is going to be a repository on DagsHub with its storage. And then what you can do with DVC, which is amazing, is that you can use the import command that enables you to import the dataset to your project. It's going to be shown in the pipeline, and then train the model. What we're going to do at DagsHub, if you're going to import that dataset and it holds on DagsHub or a bucket that is connected to DagsHub, we're going to proxy the data from that repo to the repo that you're importing the data to, without cloning or copying the data. So we're not wasting memory here. It's basically we're building this huge pipeline that enables you to view the data that you have here on the new report that you're importing it to. So this is the way that I would do that. If the data sets are fairly similar, then just version control them and then use DVC to go back and DVC and Git to go back in time and retrieve the version that you want to train the model with. And this way you can also encapsulate the results, because you're using one data set, you're running the training process, you have the result, you're versioning the result with Git DVC, or with Git with DVC, let's stay in the DVC area. And this way you encapsulated all the experiment under one Git commit. And let's say you now change the hyperparameters and you check some experiments, and then you move to a different data set or different annotations or whatever, and none provided good results, right? How can you retrieve that previous version, that golden experiment? All you need to do is run git checkout command, and bam, you got it. Did it answer your question, Jacob?
Yes, thank you.
Sure. Kai, is DDA functionality especially useful for training deep learning models, or do you see other use cases for it as well? So DDA is project agnostic. It works well with neural net. It works well with statistical models. It works well with like different on different use cases. What the sensitivity the DVA has is the framework that you use and the OS level script that you use. So based on the way that you're opening the files, DDA will enable to support those formats. So let's say it really shines and works very well with PyTorch and Keras, but TensorFlow that uses C or C++, it has some challenges. So if you're using Keras from TensorFlow, it's going to work. If you're going to use only TensorFlow, let us know, and we will get another ping from the community that it's important to extend the its support. Basic scikit-learn models does not support learning in batches or particular learning, hence my question. No, but you can also, let's say you have a huge data set and you don't want to download all the data to your local machine. You want to download a batch or train your model on a subset. So with DDA, you don't really need to pool the entire data set. And also the same if you're uploading a new subset. So let's say you're using sklearn and you have some predictions that you're doing and you want to upload a sample of those predictions to your repo. So you can do it with DDA right away. So you can upload your data and version it either with Git or DVC. Sure. The last command, python-m, gives me an error, no such file or directory. I will need to take a look into it. Are you using GPU, JP? So change the runtime to GPU, because as I mentioned, it depends on the framework that you're using, and because I'm using Keras here, and Keras version that communicate with GPUs, and it's sensitive to the way that it opens files there. So if it uses os.open file, not OS, the way that it opens files. So if you're not using a GPU, then once again, I would refer you to the support metrics that we have on DagsHub. But in order to use it, you need to change the runtime to GPU specifically for my project. So it's not for other projects, let's say that using TensorFlow, using PyTorch, it doesn't relate to which framework or hardware you're using. Sure. Okay, so 20 minutes behind. Sorry for for extending it, but we had some great questions. And I felt like we had a great vibe. So thank you all for joining me today. I want to thank also Megan for helping me in organizing it, and for Kirill for debugging a lot of stuff, and for all the DagsHub team who helped build this presentation. And I want to thank you all for joining us. And feel free to jump to our Discord, to our community Discord. We have a lot of interesting topics that we're discussing there, unrelated to DagsHub. So it's more of an ML community that share knowledge, share projects, and also ask general questions. And we love also to hear about your challenges, the things that you're working on, and what are the walls that you're hitting, and maybe to help you out with them. So feel free to reach out on our Discord channel or on the Discord server. And if you have any more questions, thoughts, comments, leave them on LinkedIn, leave them on Discord, wherever you feel comfortable. And that's it. Have a great rest of your day, night, maybe good night in part of the world. And see you in the next webinar. Bye-bye.